clear things up, what you guys do. So Marcel, you are a software developer for R&D at RAMPF Group.
Yes.
Olgierd, you are the CEO of Novicos GmbH. And Christian, you are the product manager for LiveTwin on Industrial Edge / XDT. We'll get to that later. So it's great to have all of you here. Thanks for bringing your partners and customers here, as we do throughout the entire stage program. Marcel, I'd like to start with you. Can you maybe give us a brief overview of what you guys at RAMPF Group actually do, and also, or in particular, your work in the field of adhesive applications?
Yes, so in RAMPF Group, we specialized on chemical processes. And within the group, we have more companies specializing on different parts of the whole process chain. Mm-hmm. So we have one company that produces and develops materials. We apply them ourselves and do the recycling. And where I'm at RAMPF Production Systems, we build machines to apply those materials in industrial processes, mm-hmm. Which means sealing, gluing, or potting applications.
Okay. And Olgierd, now over to you. So what's the connection to simulation and ultimately, obviously, to your company, to Novicos?
Yes. So we're an engineering company based on, I would say, quite simple experience that the great innovations happen when simulation and test come together. Whenever we go, whatever project we run, developing new product or solving a troubleshooting case, we see the same pattern, combining real test and numerical simulation creates solutions that are faster available, more reliable, and more robust. Mm-hmm. So this is what we do.
Okay.
This brought us naturally to Siemens because there is no other company with such a great solution portfolio for both hardware and engineering software. We've been working hands-on with this tool since 2003, gathering some experience across different domains, across different continents as well. Mm-hmm. Even though we are located in Germany, our projects, our work reaches far beyond, throughout Europe, to the Arab countries and across Asia. But whenever we go, the tasks differ, but the principle works the same. Mm-hmm. Simulation and test connected.
Okay, great. Awesome positive words already there about Siemens, Christian. That's the way we like it.
Thanks a lot.
I'll spare you the introduction of Siemens because obviously we all know, don't we? Marcel, I'd like to continue with you. I think we have something that shows exactly what industrial glue dispensing is all about, right? So what can you tell us?
Exactly. I've brought a video and we see different processes and some examples of what we handle or our machines handle. So we see potting processes. Okay. Or we see the application of beads. Mm-hmm. So we started the project with a focus on gluing. So we see the application of glue on a part. So we applied those beads, and the amount along the dosing contour has to be exact to produce exactly this size of beads. And the material only gets mixed in the mixing head and then starts to react and the glue starts to stick.
Okay. Perfect. Yeah, I just wanted to make sure we watch it to the end because we want to see the whole thing. So, I mean, Marcel, I'm not seeing many faces here that are going, huh? It seems that you have everything under control, right? So where's the problem? Why do you need us?
The problem is we need very high accuracy already, which is already quite the problem to get in such exact properties. But then we have either the bead geometry, so the exact dosing amount along the whole contour, or for the potting applications, we need the total amount to be exact and allow for some fluctuation. But we have two main factors that we want to eliminate with this project. One is fluctuation in ambient temperature and variation by batches of the material. Both influence the viscosity of the material by a lot, and the viscosity changes the process, so the dosing amount. And we can only measure worse than we already dose, so we can't improve it by measuring. And checking the product is only possible in gluing applications after the glue hardened. So the glue is hardened and the process has to continue. So I produce way more parts until I can check the part if it's okay. And then I have to make a pull test. And if it holds the defined amount of force, then the part is fine. But if it's not good, I risk to have already produced a lot of more waste. So we want to dose exactly to not risk making waste.
Okay. So Christian, where others see challenges and problems, we see opportunities, right? So, and I think the opportunity here is really to obviously understand and then optimize the process even further. And for this, just like for many other things, we have an entire product portfolio, right, available for our customers. And this is where the XDT comes in, the Executable Digital Twin. So what can you tell us about this?
Yeah, I would like to give you an introduction about executable digital twins and what we can contribute for these challenges. So we have a portfolio that can start with simulating the processes in detail on physics-based simulation, and also bring this to the shop floor and integrate it there. On the slide, you can see two areas where we can contribute. One is for monitoring analytics to get more process insights, get some details, what is going wrong or where can be optimized. But also, and this is what we did together with RAMPF and Novicos, a closed loop optimization. So we really bring this simulation model to the shop floor, execute it there, and give the PLC valuable feedback about the actual process to optimize it.
Can you go even deeper into the technical aspect?
So in detail, you can see the Simcenter portfolio, which Olgi had also tackled in the beginning, where we have a wide variety to simulate topics for physics-based assets, for fluids, structural elements, as you can see in the circle. And then we take this very same model, export it, and make it executable. Like you can imagine this like a function block with inputs and outputs, collecting the data from the PLC, from real-world values, calculate and process them, and come up with new virtual values. So we call this also virtual sensing. And there we have a lot more insights then that can optimize the machines.
Okay. Now I think one of the important things in there was Simcenter Amesim. So Olgi, how was this used in the project?
Yes, this is what we did, working closely together with colleagues from RAMPF. We started by generating the first Simcenter Amesim model of their dispensing unit based on the CAD data and some nominal process parameters. Yeah. Then refining this model using available physical values from the machine, and finally verified its accuracy with results from additional measurements that were done for further operation points. From the very beginning, it was important, and it was our goal to develop a model that is not just running, but truly reflecting what's taking place inside the machine. To get there, we followed a step-by-step procedure. The entire quite complex, very complex system of RAMPF machine was subdivided together with RAMPF team in subsystems, first conceptually and then one by one inside Amesim. Each subsystem was modeled separately, compared against available data, and improved until the results aligned. Based on it, we were able to go further and derive out of the Amesim model the real-time capable digital twin of the considered machine. And this is a step, I would even say a milestone toward virtualization and optimization of the processes. And the next step is together with Siemens automation colleagues to implement this digital twin into the control environment of the machine.
Yeah. Christian, I mean, Olgierd just said it there. It's such a complex system as it is. So in your view, what was it like? Because I assume there were some challenges, right? Integrating this simulation model, which is also complex, into this system. How did you go about doing that?
So yeah, you're right. So it's indeed a complex system and complex simulations, but for the automation engineers, we simplify this a lot. We just package it as XDT in the format of an FMU, which is standard format, and deploy this to the industrial edge. There we have standardized apps. So we have LiveTwin as an execution runtime and the XDT gateway to support this deployment. And what we now do, we integrate it to the PLC via Profinet. So I guess most of you have heard Profinet, our field bus, and which is per definition, it's a real-time bus, a deterministic behavior. And this is how we can integrate it directly to the machine, like a real sensor. And this is a new functionality we offer now, and we use already with RAMPF for this realization.
Right. Olgierd, moving away from the technical aspect of things, can you tell us how the project actually developed and what results or learnings that you can share?
Yes, so now that we have the two models, the Amesim model and this executable twin, it's like you're suggesting, a good idea to have a closer look at it, what can be done with the two models. So there are essentially two ways how this model can be used. They are both powerful, but very different. First, during their development. The Amesim team is some kind, I would even say it is, a virtual workbench of the machine. One that never wears out, never fails, can be pushed to values that you wouldn't risk on the real hardware. And it gives, during the development, a chance to work with different designs, validate different components. Engineers can understand the physical behavior of the system long before anything is built. And the second possible to work with the models is during the real life operations. And this is where the advantages of this executable digital twin really comes into play. Having this model running in parallel to the real machine, fluctuations of parameters and data are not just recorded. They can be recognized, understood, and compensated. And this is a big advantage at very different levels.
Right.
The efficiency of the machine can be improved. The waste of sometimes very expensive adhesive materials can be reduced. There are also some advantages toward maintenance. And very important, this executable digital twin delivers a lot of data. And as we all know, a good data of good quality is the basis of any further AI implementations.
Okay. Now, we're slowly but surely coming to an end, but I think that all of you have a few final things you want to give to our audience. Marcel, maybe we can start with you. I think you have something about customer zero approach, right?
Yes. So we now have a good starting point, but we, on one point, focus on gluing processes And as I mentioned, we also have other processes that we take into account. So we have to further increase the model. We want to get more data, or that we simulate, so that we calculate, that we actually can't measure. So the aim is to reliably tell if a part will be good or not, to stop producing waste because of variation in temperature or by batches. And with the customer zero approach, we now have a starting point for gluing. And if someone is interested to work with us, we can go from there and develop a bigger model to reach our goals and further make a more precise and more robust process.
Okay, thank you. Olgierd, how about you? Any final statements?
Yes, I really believe that this executable digital twin has potential to change any complex production machine from something that is operated to something that is actively collaborating with its users, with its data, and optimizing its performance. And it all is based on a validated Amesim model, and this example shows that this is really possible.
Okay, great. And Christian, what about the Siemens perspective?
Yeah, first of all, I want to thank you for this good collaboration we did with RAMPF and Novicos. It was good progress so far. And also I'm looking forward to implement this to real productions. So far we do it in the test environment, but of course we want to make benefit for other customers also. And also if you are interested more to see, we are representing it on the fair. You can see our booth 68. And I invite you to come there to meet the three of us and go in direct discussions about this topic.
The perfect way to end, I'd say. Can I have a big round of applause for my guests? That was a really great talk. Thank you so much, Marcel.
Thank you.
Olgierd and Christian. Enjoy the rest of SPS, and thank you so much for making the effort, yeah? We hope to see you again soon.
Thank you.
Thank you. Bye-bye.
Bye.